All right, in this video, I'm going to cover the last part of the lesson, pages 8, 9, and 10 from class. So we're going to do a little more work with the calculator that we did before. I put concrete steps on how to do it here, just like I showed in the previous video as far as entering the data for the list for the student's arm spans and how to calculate those one variable statistics. So you would need to do that here. They purchased some pumpkins, they weighed them. This is quantitative, don't forget about that, weight in pounds. So I could do a histogram, a stem plot, a dot plot, a box plot. So now we have 4 different graphs for quantitative data. And they said to calculate the mean. So I plugged all this data into a list. I calculated the mean and the median. You might want to take a minute and do that depending on how proficient you are with your calculator and if you feel like that's going to be beneficial or not. And then question 3, it's asking, would you use the mean or median to summarize the typical weight or the center of the distribution and why? So what I'd like for you to do, pause the video, answer that question, come on back, I'll explain it. So it really has to do with the shape of the distribution. You'll notice I drew a curve over the histogram, helps me see the shape. There's more of a tail on the right, potential outlier between 30 and 35 pounds, or a couple of them. So the distribution is skewed to the right. So I'm going to use the median, and I'm going to have to explain kind of 2 levels. Because the distribution is skewed right, and the median's resistant to that skewness. Resistant meaning it's not going to change at all or not going to change very much, where the mean would. Okay. Actually, I want to say one more thing here. If you look at the mean versus the median, you could see the mean is higher than the median, and that's what we talked about previously. The distribution skewed right, the mean will be higher. All right. Page 9 gets into actually calculating a median without all of the data. A histogram doesn't give us the exact data points. Here's what I know, a random sample of 94 students. So really, if I were to number these, if I were to put all of this data into a list from least to greatest, there'd be 94 data values, and I want to find the middle one. 94 is an even number, so just a reminder, if you have an even amount of data values, this is even, you're going to end up with 2 in the middle that you have to take the average of. So here's what I did. I'm taking 94 divided by 2. I get 47. So I need to find where the 47th and 48th score fall in this histogram. And then I can figure out which interval contains the median. So I can't tell the exact frequencies, but I know there's about 22 that fall in the 80 to 100, and then there's about another 40 that fall in the 60 to 80. So that means the 23rd, 24th, all the way up to the 62nd score is going to fall in this interval. So that means the 47th and 48th score are going to fall there. I started at the top. I could work from the bottom and say, all right, maybe this is 3 plus 9. So this will take me through the 12th score plus about, let's call that 20. 12 plus the 20 is 32. So this takes me up through the 32nd score, but I'm not at the 47th and 48th yet. So 32 plus the 40, the 72. So somewhere in this interval, 60 to 80, is going to be the 47th and 48th score. We don't know what the scores are, so we can just say that's the interval that the median lies in. You may need to rewatch that. It's not the easiest concept to pick up on. Okay, on the bottom, I think you should be able to try that one on your own. There's a couple ways you could do it. So see if you can pause the video, work through it, and see what you get. You can plug this data into your calculator. Remember, for a stem plot, they have a key. So if I'm plugging this in the calculator, I would do 5, 10, 10, 15, 15, 15, 15, and so on and so forth until I get to 85. Plug it in a list, run one variable statistics, boom, get what you get. Or you could start crossing these off. This might be more time efficient. But just be mindful that you're crossing off the lowest and the highest each time. You do end up with 2 left, 0 and 5, but that's not 0 minutes and 5 minutes because the stem is 2, so you really need to take 20 plus 25 and divide by 2. So either way, calculator or non-calculator, you should get 22.5 minutes. All right, on the last page, you have a check your understanding on the top. go ahead and do this on your own. And then after you've paused the video, come back and watch me explain it. See how you did. So it's the same data. They want to know, would you expect the mean to be greater than, less than, or about the same as the median? This is all about the shape of the distribution. So there's the curve I put over the distribution to help me see the shape. It goes least to greatest, 0 to 8. So the tail is on the right. This is skewed to the right. That tells me the mean is going to be bigger than the median. Why? Because of the skewness. Number 2, use your calculator to find the mean travel time. I'm noticing I did not do that, so I will do that real quick while I'm talking through the other one. And the last one, would you use the mean or the median for a more appropriate measure of the center? Because the distribution is skewed, and we talked about the fact that skewness, mean is not resistant to skewness, I would use the median. Mean is not resistant to skewness, so I would use the median. And I feel like I left some data out, so hold up. All right, 5, 10, 10, 15, 15, 15. Oh, there's another 15. 15, 20, 20, 20, 25, 30, 30, 40, 40, 45, 60, 60, 65, 85. All right, got them all in there. Boom. Okay, the mean is 31.25 minutes. So that's what the mean time is. And then just rehashing number 3, using the median for measure center because the distribution is skewed right and median is not resistant to skewness. This little applet just goes through comparing the mean and the median. It allows you to make a dot plot and look at the mean and the median. Just going over if it's skewed to the right, the mean is greater, skewed to the left. And you can see how moving each point affects those. So it's kind of cool. And then summary. You should be able to look at each histogram and do A through D. So I would pause the video, come back when you're done, and then take a look at how you did. So for the first one, the histogram skewed to the right. So I'd use the median and IQR for measures of center and variability, and the mean would be greater than the median. The center histogram is approximately symmetric, so I'm going to use mean and standard deviation, and the mean and median are roughly the same. And the third one, the histogram is skewed to the left, so I'm going to use median and IQR, and the mean would be less than the median. So again, I apologize about that 10-minute hiatus in class today and the fire drill. I couldn't control that. So if you do have questions after watching these 2 videos, please send me an email so that I can explain things or send me a message on Remind. I hope you have a good weekend, or whenever you're watching this, hope you're having a good day. Adios.